What's up? What's up? It's your boy, the network. Today's topic is section 6.4b, NTP authentication. This is a topic in the CCNP route exam. It will be known as CCNP Enterprise exam come February 24th, 2020. Let's go ahead and take a look at the exam blueprint, see where we came from. Hashtag LabEveryday. Go ahead and visit labeveryday.com. All right, this is the exam blueprint right here. Implementing Cisco IP routing. Exam code 300-101. It'll be known as exam code 300-401. We just wrapped up the section NTP master client version 3 and version 4. We just kind of discussed version 3 and version 4. We didn't really configure it really. I don't think it's supported on Boson Netsim. Today we're going to be doing NTP authentication, and we're going to also perform that in Boson Netsim. After that, we'll finally move on to IPv4 and IPv6 DHCP, which we really did cover earlier in this section right here. DHCP relay and server. This was just to identify and configure the IP addressing for it. So we'll probably just maybe dig a little deeper into it because those topics go hand in hand. But anyways, what is NTP authentication? Well, if you remember from the last video, we know that NTP stands for Network Time Protocol, right? It is a protocol we use to have our networking devices agree on the same time. Simply put, authentication obviously is what? For, username and password, or to verify someone's identity before they get onto our network, right? Or use our services, whatever the case may be. Well, NTP authentication, we just take those two concepts and combine them together, right? Really, NTP, if you don't set it up right, or if you don't have it set up really secure, it can be kind of like a security flaw on your network. If a really smart hacker can hack your network by using NTP flaws, because they see, oh, he didn't put an access control list on this network. Bam, I got him. And they can just pretty much get onto your network and do whatever they want with it, right? Remember we was talking about time-based ACLs. If they can change the time basically and be like, okay, now I can access this server, and so on and so forth. There's so many ways to hack a network using NTP. Now with NTP authentication, this is a way to harden our network via NTP. There's several ways harden our network, obviously, but some of those are going to be out of scope of this exam. If you want to study more of that stuff, you study CCNA security or CCNP security. Those are more security topics. NTP authentication would be one of those topics, right? So let's go ahead and take a look at the official definition here. Okay, NTP authentication. The authentication is mainly used to prevent the tampering with a timestamp on the logs which is generated by the device. To implement the attack on NTP, the hacker may make their rogue host appear to be the valid NTP server, right? So they can get onto your network and be like, hey, I'm the NTP master, right? It's spoofing the network in a way. Hence, the NTP authentication is used to authenticate a time source, not a client. So we're not just letting them on and then asking a device for authentication. We're authenticating a time source, not a client. Remember that. NTP can be secured using authentication and access lists. To use access lists, simply write an ACL, blah, blah, blah. We know about ACLs. We've covered that in a couple videos back. But here's another recap right here. Just a simple access list. Use this is a numbered one. It's a standard, right? Permit, we're only permitting this address. After that, everything else is denied, right? Because there's an implicit deny after every ACL, at the end of every ACL, right? And then we can do NTP access groups. Here's the configuration of it, just NTP access group. You have options. We'll probably look at that by just hitting the question mark. This number 10 is referencing that access list right there. Access group options. Here are the options right here. The access group command has these commands or these options ordered from least restrictive to the most restrictive. This is the order they are scanned, right? But remember, it'll check the ACL first. If you don't match there, then it'll go here. But if you don't match there, it'll deny you because there's an implicit deny at the end, right? But anyways, this is least restrictive. Peer enables the device to receive time requests, and NTP control queries and the sync itself to servers specified in ACL. Then there's serve enables the device to receive time requests from the servers specified in ACL, but not sync itself to the servers. Serve only enables the device to receive only time requests from the services specified in ACL. And query only enables the device to receive on the NTP control queries from the servers specified in ACL. If you want to pause it, freeze frame it, I don't want to get too deep into this because we got a long lab to get into here with Boson Netsim. A little further information on access groups. Although NTP scans the group options that we said, it scans these options in order, right? It'll look for this, then this, then this. This is most restrictive, right? If NTP matches a deny ACL rule, ACL processing stops and does not continue to the next group option. If your router is configured as an NTP master and you are using a access group, you must allow peer access to this IP address. Remember, we talked about this IP address in the last video, right? 127.127.7.1. This looks like an IP address we need to remember if we're going to be talking about NTP protocol, because this is the IP of the internal server created by the NTP master command. Remember in the last video we did NTP master, and then we said, what is the IP address of the reference clock? And we went on the master, checked it was, and it was this IP address. This is a loopback address, but it's a loopback for NTP masters. So remember this IP address. This looks like a question that might be on the exam. So remember that address, 127.177.7.1. It's the NTP's reference clock IP address right there, right? If you do not allow it, the server will always be out of sync. You can also configure NTP authentication to use the MD5 hash. Remember, this is hashing, not encryption. To do so, you configure an NTP authentication key, which we'll do, I believe, in the lab. Matter of fact, here goes some configuration examples. You do this on the server, right? NTP authentication key, give a key number, MD5, or choose the hash. I believe it's just MD5 is the only one that's supported on this simulator. This is why I like hardware, because you'll have way more options. Also GNS3 and other emulators, because they're actually using the real iOS. But you know, it really makes it easy for me to explain when I'm using Boson Netsim and Packet Tracer, which we haven't used in a while anyway. But you know, it is what it is. Some of these commands, that's why it's best to use GNS3 even when you can set it up. I know sometimes it's a little difficult to set up, and definitely use live hardware, because you know, in the real world, you're not going to use simulators. You're going to be using hardware, right? So, and this is what you do on the client right here. You'll notice NTP does not authenticate clients. It only authenticates the source. I'm going to reiterate that. It does not authenticate clients. You authenticate the source. So you're saying, is this a real NTP master? Is this a real NTP server? Let's authenticate him. We're not authenticating clients. We don't care about the clients. We don't ask clients for the time. We ask servers and masters for the time, right? This is why you should always use access lists to limit NTP access to your servers. Let's go ahead and fire up Boson Netsim. I know it says Switch Lab, but because the way they ordered these labs, they just put it in the Switch Lab. I believe because this is an older version, and maybe this topic was more of a Switch topic, but nonetheless, it's a CCNP route topic. All right, so here's the lab we're going to be working with today. We got router 1, distributions switches 1 and 2, access switches 1 and 2. And then we have these PCs right here. Don't worry about those for now. And this is just some basic information about NTP security. I know it says Switch Lab here, but this is, I think back then maybe it was more of a switch topic, and they moved it over to routers. But nonetheless, we are covering it, NTP security, for the route exam. Again, here's another picture of the lab if you want to look at that. Here is an access list, which we know how to do. Here's some basic commands we know how to check, set the time. Here are these NTP commands right here. Right, then we have some show commands for NTP. Here's the IP addressing guide. We can skip that right there and just start with configuring NTP and NTP security. So first thing we're going to do is configure NTP, which is basically a review of the last video. It says here in the task you will configure NTP on router 1 on all these guys right here, and privileged exec mode and global config mode, and say, actually to set the time you don't need to do that. You go to user exec mode, privileged exec mode, say clock set the clock to 6:09. So when you got to do 18 because it's military time, 18:09, 0 seconds, and then he said the date was the 26th of August 2014, right? Yeah, I see how old my software is, right? On router 1, verify the current time. From what source is the time and date set? So we verify time with show clock, right? Time and date is finally set just correctly. What source is the time and date set though? We say show clock detail for that, and it says the time source is user configuration. Basically, I made a time. Question 3, on router 1, enable NTP by configuring router 1 as a master NTP server. Use a stratum of 10, right? Y'all remember how to do that. We said that in the last video, right? This is more of a review of last video. We said a stratum is how many hops away you are from the most authoritative time source, right? So stratum 0 are atomics, clocks, and GPSs, right? So with stratum 10, we are 10 hops away from the top atomic clock. And this is, we're going to talk about this further, right? So we're going to say global config mode, say NTP master 10, right? Next question is, what is the importance of the stratum value in NTP? Well, we just mentioned that. It's how many hops you are away from the most authoritative time source, which would be the atomic clock, right? The default value, remember what the default value is? On Cisco iOS, it's 8. It's 8. On router 1, verify the current time. Now, so from what source is the time and date set? Now, we said it was user configuration before. We say show clock detail. Now the time source is NTP, right? So this is just a review from last video. Question 6. On both DSW1 and DSW2, display the current time. Is the time on either DSW1 or DSW2 synchronized with any time source? Probably not, but let's check. Show clock. So he is in 1993. He's back in time. Show clock detail. No time source. Same thing with this guy. Enable. We'll say show clock detail. No time source on both those guys, right? Question 7. On DSW1, configure NTP to synchronize the time. DSW1 to synchronize the time with router 1, this guy, through router 1's FA00 interface, which is located right there. Right there. This interface right here. So we're going to go to router 1 and see what that address is. Show IP interface brief. He said the FA00 interface is 51.49, right? 192.168.51.49. And we say to synchronize our time, we're going to go to global config mode. We're going to call him an NTP. He can't be the master. So in this case, he'll be a server because peer is not supported on this. And we're going to configure him as a server so that way anybody below us can synchronize their time to us. So we're going to call him a server, right? And we're going to synchronize the time router 1's FA00 interface, which was what? 192.168.51.49. And then on DSW2, go to DSW2, configure NTP to synchronize time through router 1's FA01 interface. So he's going to do it on this interface. That's where he's going to be synchronized against time. So now we do global config mode, NTP server, and it's 192.168. What is the FA01 interface? 51.43. 51.43. Question 9. On both DSW1 and DSW2, display the current time. Is the time synchronized as an NTP source? So we do show clock detail. Time source is NTP. Yes. What about DSW2? We say show clock detail. He has no time source. We'll keep doing that. Keep doing that. No time source, right? While that's synchronizing. On DSW1, examine the status of NTP. What stratum is being reported? Let's double check on router DSW2 though. He's still showing himself in 1993. Come on, man, get with the times, bruh. Didn't we set it to the correct IP address? Let's double check. Pretty sure we did. Yeah, NTP server 51.43. 53. See that? 53. We need to change that. I'm glad we did. I'm glad we checked that. 51.53. Okay. I'm pretty sure he'll work now, right? So on DSW1, examine the status of NTP. Show NTP status. What stratum is being reported? Well, he's reporting stratum 11. Why? Because he is 10, and since he's a server, he's one hop away, he is 11. And you keep going down the further away you are the clock, right? That's the higher your stratum are. The lower your stratum is, the more accurate or more believable the time as an authoritative source. Let's go to DSW2, see if he synchronizes time yet. Show clock detail, and there it is. That fixed it. So we had the wrong IP address there, right? On DSW1, examine the NTP associations. We go to DSW1, show NTP associations. From where is DSW1's time being synchronized? Well, his time is being synchronized from 51.49. Who is that? That is router 1's FA00 interface, right? What is the stratum of the NTP source? Well, we see here the stratum is 10, right? But my stratum, his stratum, so he's 10. What's his status? We said that already. We'll double check. Show NTP status, and his stratum is 11, right? Task 2, configure NTP source security. What we came to do, Cisco devices can use NTP authentication to verify the source of NTP packets. In this task, you will configure NTP authentication on router 1, DSW1, and DSW2 so that packets from router 1 are verified by DSW1 and DSW2 before they use those packets to synchronize their clocks. Okay, so on router 1, display NTP associations. We can just do show NTP, these leading questions here, right? Associations. What authoritative source is being used to synchronize the time? Well, looks like here we are using ourself, the reference clock is ourself. Remember, this is the NTP master IP address, right? This is like the special reserved IP address that we use for NTP master. It's like a loopback address. So that looks like a question that might come up on the exam, because I see we talked about this in the last video. His stratum is 9. On DSW1, display the NTP status. So NTP status on DSW1, show NTP status. Is DSW1 receiving its time from router 1? It says here reference is 192.168.51.49. So yes, it is. We could also just do a show clock and see the time has updated, right? On router 1, enable NTP authentication. How do we say we do that? NTP authenticate. You can do it in either order. You could do the key and then the password, or the key and then the password, the MD5 hash password, and then do authenticate and then enable it. But in this case, you know, this is a configuration. That's why I said these are examples. You know, you could enable it first and then create the key, or create the key and then enable authentication. So in this one, they want us to enable authentication first. So we just do on router 1, we enable it by global config mode and say NTP authenticate. Right now it's enabled, right? On router 1, configure an NTP authentication key that uses ID of 1 and a password of Boson. How does NTP use its authentication keys? Right, so first let's create the authentication key, which is NTP authentication -key. And then the key number was 1. It says here they want after that the MD5 authentication, so we did MD5. And then we create the key, which is BOSON, all lowercase, right? On DSW1, display NTP associations. Is DSW1 still synchronized with router 1? Why or why not? So we go to DSW1, show NTP associations, and we see here that is his reference clock right there. Oh, that's his reference clock. And the address is 192.168.51.49. So that is the master, and this squiggly line here lets us know that it's configured. Here, let me show y'all. Get myself out of the way, and you'll see it says here that squiggly line. That's, remember we said that in the last video. That was the pop quiz. It stands for configured, but what is the official name of that squiggly line is what the pop quiz was, right? So this is a mastered, synced, configured clock, right? Why is it still configured? We don't authenticate peers. We authenticate our time source, right? On DSW1, configure NTP to use authentication. So on DSW1, we just say global config mode, do the same thing, NTP authenticate. Step 7, configure an authentication key that uses an ID of 1 and a password of Boson. So same thing we did. So on DSW1, we're going to say NTP authentication -key 1 MD5 Boson. On DSW1, configure NTP authentication to trust packets from only NTP devices that authenticate by using authentication key 1. What will DSW1 do with NTP packets that claim to be from router 1 but that do not use the trusted key? We said to configure a trusted key is just NTP on the server, NTP trusted key. We do the same thing on clients. In this case, he would be a server, so it's pretty much the same configuration. And remember this note here, you'll notice that NTP does not authenticate clients. It only authenticates the source. This is why you should use access lists to limit your NTP access to your servers. So we just say on this guy, NTP trusted key, and he said authentication key number was 1, right? What will he do with NTP packets that claim to be routed from 1 but that do not use the trusted key? Well, he should drop it. So on DSW1, reconfigure NTP to synchronize over router 1's FA00 interface. You should modify the configuration so that it uses authentication key 1. Synchronize over FA00 interface. So basically, we're going to put that same command in from before. So we're going to say NTP server 192.168. The FA00 interface is 5149, right? 51.49. And then use key 1. So now we got to do peer key is 1, right? There. So that's a tricky part right there. On DSW1, display the NTP status. So NTP status. Is DSW1 still synchronizing its time from router 1? Let's see. It says here, clock is synchronized, stratum 11, reference is this. So yes, he still is. Let's verify that again. Show NTP status. Looks like it still is, right? So on DSW2, configure NTP to use authentication. So we go to DSW2, and we said to do authentication is what? NTP authentication, authenticate, right? That's enabling it. Question 12. On DSW2, configure an NTP authentication key that uses ID of 1 and password of Boson with a $sign though. Ensure that the password is not identical to the password configured for authentication key 1 on router 1 on DSW1. So we say NTP authentication -key. We said 1 MD5, and the password is BO $ON, and that's pretty much it. Carriage return. Make sure it's not the same, because last time it was BOSON. This is BO $ON, right? On DSW2, configure NTP to trust only NTP devices that authenticate by using the key of 1. So now we're going to say NTP trusted key 1, right? Question 14. On DSW2, reconfigure NTP to synchronize over router 1's FA01 interface. You should modify the configuration so it uses authentication key 1. So we go to DSW2, reconfigure it. So we say NTP server. And what was the FA01 interface? FA01 is 5153. 5153. So 192.168.51.53. And we said the key is 1, right? On DSW2, display NTP associations. Is DSW2 still synchronized with router 1? Why or why not? So we do show NTP associations. We still look like we're synchronized with that clock, FA01, right? Oh no, look at that. We just refreshed, and now we got a hashtag here. What does this hashtag mean? Master unsynced. Why not? Because we gave him a trusted key, but it's different from, we didn't give him the trusted key yet, right? DSW2, remove the NTP configuration. How do we do that? Right here at the top. No NTP. Removes an entire NTP configuration from a device, including any authentication or access groups configured on the device. We'll go to global config mode to do that. No NTP. That removes it. Says here in DSW2, configure authentication, including an authentication key that uses the ID of 1 and a password of Boson with the correct password, right? Ensure that attempts to sync over router 1's FA01 interface. So now we're going to put the correct password this time, right? So now we say NTP server, and then the server is on FA01 51.53, right? All right, so 192.168.51.53, and then we said the key is 1 MD5, or my bad, we need to do 51.53. Oh, we need to do authentication. We do NTP authenticate. Let's verify that's still in there. Do show run real quick. Do we have any NTP? We removed everything, so we look like we got to do everything over again, right? So NTP authenticate, NTP authentication -key, and then the key ID was 1 MD5 Boson, and then we need to synchronize over FA01 interface, so we need to do that over again, I believe, right? So we say NTP trusted key is 1. We also want to do NTP server is 192.168.51.53, right? And then we're going to say key is 1. So pretty much got to do the whole configuration over again. And now let's see if we got the correct time associations here. So show NTP status. Right now the clock is unsynchronized with a stratum of 16, but it should, let's do a show NTP associations. There's a reference clock. Now if we check the status, now synchronized. Y'all see that? All right, let me bring myself back here. Task 3, configure NTP client security. Although NTP authentication verifies the source of NTP packets, it does not prevent NTP clients from synchronizing with other unauthenticated sources. In this task, you will configure ACLs and NTP access groups to ensure that router 1 can synchronize time to only DSW1 and DSW2. So router 1 can only synchronize its time to DSW1 and DSW2 at this point, right? You will also configure ACLs and access groups on DSW1 and DSW2 to ensure those devices can receive their time only from router 1. So on DSW2, display detailed information about its associations. Show NTP associations. Is it detail? Yeah, detail. Okay, so we got a lot of information here, right? Is NTP on DSW2 synchronizing with router 1? Well, let's see here. It's synchronizing. It's configured, authenticated. Our master looks like it right here, right? So here's our time. Y'all notice like NTP can be a really deep subject if you really, you know what I'm saying, really want to get into it. You know, there's also a PTP if you don't know. That's a precision time protocol. I think that's used by like financial institutions and stuff. That's beyond the scope of this exam, but that's just to let you know how many, you know, time protocols there are out there and how deep you can get with this. Now, look, we just did association details. Look at all this information we got. Anyways, question 2 says on DSW1, display NTP associations. Show NTP associations. Is NTP on DSW1 synchronizing with router 1? It looks like it. Yes, it is, right? Master synced, and then this means configured, right? On router 1, create an ACL. Let's go to router 1 with an ID of 10 and configure it to match permitted traffic from DSW1's Fast Ethernet 06 interface, right? So we're going to say, we're going to global config mode, first of all, right? And we're going to create an ACL access list. We said 10. They didn't say extended or anything like that. We're going to permit traffic from DSW1's FA06 interface. So what's DSW1's FA06 interface? We'll do a show IP interface brief. And we're going to exclude, because this is a switch, the unassigned interfaces. I guess that don't work. I keep forgetting. This is simulator. This is why I like using hardware. But anyways, 51.50 is what we need to permit, right? What's the subnet mask, though? Well, let's just permit just that address, right? FA06 interface, right? I believe that's /24, but whatever. Let's do show IP interface. FA0/6, right? Yeah, 51.50/30 interface. So we're going to go to here, router 1, create that ACL. We said 192.168.51. What we said, 50? 51.50/30, right? So 51.50. We're going to permit just that address. Or do you got to do wildcard mask? Yeah, I believe you got to do a wildcard mask. So we'll just do the exact address by doing all zeros, right? On router 1, configure, let's go, configure NTP to synchronize its time only to DS1 and to not permit NTP control queries on ACL 10. NTP should not be able to synchronize router 1's time from DSW1. So this is pretty tricky, right? Router 1 configure NTP to synchronize its time only to DSW1 and to not permit NTP control queries. So we know we need to do an NTP access group, right? Let's look at our notes here, right? We said for access groups, the access group command has these options, ordered from least restrictive to most restrictive. This is the order they are scanned. We said peers enable the device to receive time requests and NTP control queries and sync itself to service. I don't think that's it. Let's see what options so that way we can look by just doing the question mark, right? So we know we got to do NTP access group. And to do that, we said it's just NTP access group. And it will see our options from that point and look at the notes on what they exactly wanted us to do. So we said NTP access group. And here we go. It says here, peer provides full access, right? See how simpler that is rather than reading that long ass definition? Allow only control queries. He says here to not permit NTP control queries that's the key phrase right there. So not allow control. So this allows only control. We don't want that. This provides server and query. So we don't want that. This provides only server access. So this looks like the keyword we want to use here. Serve only. So it's only going to serve. Provide only server access, serve hyphen only. And then the IP access list we need to reference is using ACL 10. So we do 10 here, right? Next thing says on DSW1, let's go to DSW1, display NTP associations. We do that with show NTP associations. Is DSW1 synchronizing its time with router 1? Let's see. So far, it is master synced, but it doesn't look like configured. Oh, yes, it is. We still got that symbol there. So configured. What if we do it again? Yep, still mastered and configured, right? So on DSW2, display detailed information about its association. So DSW2, it will do show NTP associations detail. Is DSW2 synchronizing its time from router 1? Let's see. Configured, authenticated, our master, stratum 10, reference ID is ourself. Is he synchronizing his time from router 1? 51.53. What IP address is that? Show IP interface brief. I know it's on router 1. 51.53 is FA01 interface. Is that what he is connected to, though? FA01 interface. What's connected to that? Show CDP neighbors. DSW2 is on the, yeah, so yeah, that is correct. So it looks like he is synchronizing time. Let's do that one more time, though. Show NTP associations detail. Configured and saying invalid, unsynced. Now he's not synchronizing his time. He's not synchronizing his time. Y'all see that? Because he's not permitted. He's not permitted. It denies everybody else because of the access control list. On router 1, modify ACL10 to permit traffic from DSW2's FA06 interface. Y'all see that, right? Y'all see what happened there? At first, it was configured, authenticated. Our master saying valid is stratum 10. Reference ID is that guy, right? And then he says, that is the master clock. It's configured, but inside invalid, unsynced. And now our stratum is 16. Y'all see that? So you don't trust him. We need to modify the ACL now. So we'll get to step 12 and we'll wrap this up. So we'll go to global config mode and we'll say access list, modify access list number 10. We're going to permit, he said, traffic from DSW2's FA06 interface. Oh, we got to do this on router 1. So that's my bad. I'm glad we didn't do that. So we'll go to router 1 and go to global config mode. We're going to say access list 10 permit. Who we're permitting? DSW2's FA06 interface. What is that? We'll go here. We'll do a show IP interface brief. FA06 is 51.54. 51.54. We need to allow him 192.168.51.54. We'll put the exact IP address. On DSW2, display the NTP association. So we go to DSW2, show NTP associations. Is DSW2 synchronizing its time with router 1? Looks like it's unsynced right now, so probably got to give it some time. Remember, because look, this hashtag here says on the legend, master unsynced. And then we have the squiggly line. This is configured as the master. What does that squiggly line mean? It means configured, right? It means configured. Again, what is the official name for it? That was the question for the video. I know I got to be more specific with my questions. So it looks like he still be synchronizing. Let's do it again one more time. Look, let's compare the output, right? Look at this. Take a look at these associations here, right? Right? Specifically these right here. We hit enter. There we go. Now he is a master synced, right? And then he's configured. We said that line means configured. So yes, now he synchronizes this time. On DSW1, configure an ACL with an ID of 10 and an access group that prevents DSW1 from synchronizing time with any device other than router 1. So now we're going to go to distribution switch 1, create an ACL with an ID of 10, which we did already, I thought. So we're going to say access control list. We're going to go to global config mode, access control list. Oh, we created the access control list on the router. Yeah, we created the access control list on the router. Now we got to create it on the switch. Access control list number 10 and an access group that prevents DSW1 from synchronizing its time with any device other than router 1. That's a tricky one. Okay, so yeah, that was a tricky one. I went ahead and looked at I'm being transparent here. I went ahead and looked at the answers because this was a pretty tricky one. He said create an access list of access list number 10 prevents DSW1 from synchronizing its time with any device other than router 1. So we need to look at router 1 and see where we are going to do our permit for. Who are we going to permit only, right? So show IP interface brief. We are connected to router 1 via, looks like 5149, right? Through FA00. So he's done the FA00 interface, right? I believe so. So we're going to say 51.49. That's the permit statement. Permit 192.168.51.49. And we're going to put the exact IP address there, right? This is exactly what we did on router 1, but we're doing on DSW. We did it on router 1. Now we're doing it on DSW 1, right? And that's it. It looks like we can't even log anything. We can do a show access list to kind of verify that they're matching. And now they want us to create an access group. Access. So we're going to say NTP access group. And it's going to prevent DSW1 from synchronizing its time from anybody else. So provide full access? No. Query only? No. Provide server access? Any device other than one. So we're going to create an access group that prevents DSW2, or in this case DSW1, from synchronizing its time with any device other than router 1. So we're going to say peer, and then reference the access control list number 10. That should be it right there. NTP access group peer 10. And on DSW2, we're going to do the same thing. So we're going to DSW2, we're going to go to global config mode, and then create an access control list. Number 10, permit. We're going to permit, I believe, 51.53. Let's verify what he's connected to FA01, right? So yeah, 51.53. Permit 192.168.51.53. We're going to put that exact IP address. So we're permitting, with this, we're permitting him to be our master, right? And nobody else will synchronize with us. We're not going to synchronize with anybody else. We're permitting him. We're also going to create an access group that prevents DSW2 from synchronizing its time from anybody else other than router 1. So now we do NTP access group, right? So let me show y'all. If we do NTP, we'll see what NTP access group do. It controls NTP access, right? So NTP access group, and then the access group is peer. So we're going to provide full access. It didn't say nothing about control queries, server query only, server only. It didn't say that. Just provide full access to that other device. So peer 10, and then, yeah, that's pretty much it. Now, on both DSW1 and DSW2, display NTP associations. Let's go to DSW1 since we did it already. That should be synced by now. Show NTP associations. What's the question here? Are they synchronizing their times from router 1? And yeah, it looks like he's master and he is configured, right? And that is this guy right here, 51.49, right? That is FA00 interface, right? Here to there. He's synchronizing his time via that interface. DSW2 should be doing the same thing theoretically. Show NTP associations. Same thing. 51.43. He's the master, synced, and configured, right? If it's unsynced, you'll see a hashtag like this right here. You'll see that right there. So now, and we can verify that 51.53, right? Because he is doing it through that interface, right? On router 1 and router 2, display detailed clock information. Are the times consistent across the devices? So let's check router 1. Pretty sure he will be, because we'll do show clock detail because he's the master, right? We'll do the same thing on this guy, show clock detail. Time source NTP, that time is accurate. Do the DSW2, and we'll do a show clock detail. Time source is also accurate on that boy as well. I want to thank y'all for being patient with me. I kind of struggled through this exam a little bit, or not this exam, but this topic a little bit. Please leave a comment below on what I could do and improve. Maybe I explained something wrong. I hope I didn't confuse you guys. Again, remember, this is my learning journey. I'm just sharing it with y'all. They just say if you're able to explain it, if you're able to teach it, you kind of learn it better. Plus, I go back and watch these videos. Go ahead and add me on Twitter. That is my Twitter handle. Go ahead and subscribe to this channel. Hit the like button. Share this video if you like my teaching style. For now, please comment, like, subscribe to the network.